All right. 2 socks are drawn. This is round 2. 2 socks are drawn from a drawer which contains 2 red socks, 1 blue sock, 3 black socks, and 4 green socks. Once a sock is selected, it is not replaced. This is going to be dependent. Probability of a red sock and a black sock. So there are 2 red socks out of how many total? 2, 3, and 3 is 6, and 4 makes 10 total. So 2 red socks out of 10 total socks times, because where is it? And then a black sock, right? So this is going to be multiplying. When you take one out, since it's not replaced, your total goes down to 9. The black socks are not affected by the red socks, though, so we'll use 3 for that. So 2/10 times 3/9. 2/10 times 3/9. It's 1/15. 1/15. Which, when we convert that, is going to be 0.066 repeating, or 0.067, or something like that. That's fine. 2 green socks. That's the same thing as and. It's green and green. Let me write that. So because it's that and again, this is multiplying. There are 4 green socks out of 10 at first. You take a green sock out and do not replace it, so it'll be 3 green socks out of 9 total socks. So that is 4/10. That's the wrong button. That's still the wrong button. That's 44. 4/10 times 3/9. I'm hitting every wrong button on this calculator. There we go. 2/15 on this one, which is 0.133 repeating. There we go. The next ones, 11 and 12. There are 5 quarters, 2 dimes, and 13 pennies in one bag. So 5, 6, 7 plus 13 is 20 total. Once a coin is drawn from the bag, it is replaced. So these are independent events, so the total will not change. So 2 quarters is going to be, again, it's 1 quarter and 1 quarter. So there's 5 quarters out of 20 total times, well, I guess the same thing because it's being replaced. So 5 out of 20. So what is that, a fourth times a fourth? I think it's 1/16, but I'm going to use a calculator just to be safe, as you all should. Yep, 1/16. Which is going to convert to 0.625. All right, a dime and a penny. I already know, and I'm setting this up just because I already know my totals are going to be 20 on both of them. A dime, there are 2 dimes. There are, oh, that should be than a penny. Oh, typo. 13 pennies. So 2/20 times 13/20 gets me 13 over 200, which is 0.065. So there we go on 11 and 12. Number 13, at Plenty O Ice Cream Shop, there are 2 types of ice cream cones, 8 flavors of homemade ice cream, and 6 toppings. How many different choices do you have? Now you can make a tree diagram, and I know you all love making tree diagrams. What I would use is the fundamental counting principle, where we're going to take our 2 types of ice cream cones times the flavors of ice cream times the toppings. So that's going to be 2 types of cones, 8 flavors, 6 toppings. 2 times 8 times 6. It's 96. So there's 96 choices. All right. Number 14. Diana separates her Skittles from her M&Ms. So this one actually is an interesting question. Separates is the key word here. So there's going to be a pile on one side that has M&Ms and on one side that has Skittles. For each type of candy, she has 9 red candies, 4 green candies, 7 yellow, and 5 orange. Are the events of drawing a red Skittle and an orange M&M dependent or independent? So since we've got a Skittle and an M&M, these are going to be independent. And my reasoning for that is because the candies are in 2 different piles, or the candies are separated. Candies are separated. So if we need to find the probability, it's going to be dependent. There are, let's see, 9, 13, 25 total candies. A Skittle. So I guess we need to know a red Skittle. So she's got 9 out of 25 Skittles times an orange M&M. So 5 out of 25. And since they're separated, the denominators don't change. We're not taking from one big pile of candy. We're taking from one pile and then from the other pile. 9 over 25 times 5 over 25. And I get 9 over 125, which converts to 0.072. So these guys right here, actually, I should have put them over here, but they just do that right there. Okay? These are the answers right here. Okay? Number 15, from the tree diagram, ice cream options are shown in the table. How many possible outcomes are vanilla? So we're looking for vanilla. So anytime I see vanilla, and you can underline it. I have a highlighter, obviously I'm using technology, but we've got a vanilla here, which means anything that comes after that counts. So we've got vanilla ice cream with sprinkles, we've got a vanilla ice cream with nuts, and a vanilla ice cream with strawberries. We also have vanilla down here, so these 3 would count as well. Knowing that, 3, 4, 5, 6. So how many possible outcomes? 6 possible outcomes. There we go. And number 16, what is the probability of you selecting a cup of chocolate ice cream and sprinkles? So I'm going to use a different highlighter color here for this one. Cup of chocolate ice cream with sprinkles. Okay. Here's our cup, here's the chocolate ice cream, here's the sprinkles. There is only going to be one possible outcome. So the probability of this is, it would be one possibility out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1/12, because there's 12 total outcomes on this. And converting 1/12 real quick here, 1 over 2, whoops, 1 over 12 gets me 0.083 repeating. Okay? That's it. If we got any questions, be sure to bring them with you tomorrow before we take the test.